Hi everyone, in this video I want to talk about graphing piecewise functions. Here are the two problems that we'll do, and to make sure we don't take ourselves too seriously, let's think about the fun question. If you could be an animal for a day, which would you choose? So under Algebra 2, you will find functions part 2 here. Piecewise I have seen on the test before. It's very seldom, but it is possible. There are some standards related to functions, just general functions, and piecewise can fall under that. So in case you see some sort of a graph, I thought we would graph them by hand so that you can just see all the different ins and outs of the graphs. Okay, so in this first one, we have a constant function, the 5, with a linear function, the negative x minus 3. So what a piecewise function tells you is that there are two cases here, or 3 or 4 sometimes, but 2 in these two problems. It's saying that the function is at 5 if the x is less than negative 4. So it's like one function when the x is less than 4, like the input is less than negative 4, and then it is, if it's greater than or equal to negative 4, then you would use a totally different one. So we have to somehow represent that situation on a graph, and what I suggest is graphing the line. Remember, g of x is just like a y. So if I was going to graph the line y equals 5, that's going on the y at 5, and if it's just a straight line that represents all of the points where y is 5, then we get this line right here. But see, I only want that line with one specific case. And so why don't we draw a negative 4 line? So we have dotted line right here. That is not an actual line. It's not part of the graph. It's just kind of a boundary. So we want that blue line only when x is less than negative 4. So if it's less than, note, we're going to use an open circle. If it's greater than or equal to, then it's going to be a close. Okay. So I then want to erase where I don't need this line. So if it's only x is less than negative 4, I'm keeping the numbers less than and getting rid of all the ones that are greater than. Also, if it's not including the negative 4 because it's only less than, I need an open circle at the negative 4. So then the next one would be negative 3 starts here. And then if it's a negative x slope, that's like negative 1 over 1. So I'm going down 1 over 1, down 1 over 1. And let's get it all the way to this line here. So now I want that line only when, if I kept drawing it, it'd be like this. I want that line only when x is greater than or equal to 4. So right here is where it crosses that dotted line. And I'm just going to draw the rest of my line that way. Notice it includes the negative 4, so I need a closed circle. That's my final answer. That is graphing the piecewise function. All right. Now, in the next one, we have another constant function. It's at negative 3 down here. But I only want it where the x's are less than or equal to 1. So at 1, let's put our little boundary cutoff line. And then we want to graph the part that we need. So We do not need anything that is greater than 1. We only need it at 1 or less, meaning I'm going to include it at 1 and then do it or less. So that is one part of the graph right there. And then, oh man, we have an x squared function, right? So I'm thinking of the graph x squared, looks like a parabola. And I need to graph x minus 2. I do have a video on graphing the parent functions with transformations. So like a quadratic graph, you'd be like thinking of points 0, 0, 1, 1, 2, 4. Those would be the first few points on the parabola. So if it's x minus 2, remember this means to go right 2. So I'm going to go 2 over to the right from the origin, and I'm going to graph basically like 1, 1, 2, 4 from that new point. So here we have a parabola, like this. But remember, I only want it where it's greater than 1. So I'm going to put my point here, but then I need an open circle because we are not including the 1 on that part of the function. So there you have it. You have a constant function, a linear function, and then a linear function with a quadratic. So try the practice problems. They are similar. However, one has an absolute value function. Think about what shapes we'll have for all of these. And why don't you pause the video while you try these, and I will show you the answers. Here they are. So we have an open circle and a closed circle going on. We have to think about when to use those. In the first one, it's linear and constant. And the second one, it is absolute value and linear. So notice where one picks up and the other one takes off from that endpoint. How about a quote to give you a little bit of, just motivation through your piecewise function work. There are no secrets to success. It is the result of preparation, hard work, and learning from failure. So I hope this video helped you in some way, and if you'd like to subscribe to keep up with the videos, that would be great. Feel free to leave your answer to the fun question in the comments, and I hope you have a good day.